Stop before you do anything else, before you scroll, before you check your notifications, before you decide whether this video is worth your next 10 minutes. I want you to hold one number in your mind. 300,000 kilometers per second. That is the speed of light. The absolute speed limit of our universe. No force, no object, no signal can exceed it. And if you're struggling to feel the weight of that number, here's what it actually means in physical space. In one single second, a beam of light travels around the entire circumference of the Earth 7 times. Not 7 laps around your block. 7 complete orbits of our planet. In the time it took you to read that sentence, light has already lapped this world several times over. And I need you to sit with that. I need you to actually feel it. Because in about 10 minutes, that extraordinary speed, that cosmic velocity that we as a species have never come close to achieving, is going to seem completely, humiliatingly useless. That same beam of light, moving at 300,000 kilometers every second without pause, without rest, would need 100,000 years to cross our galaxy from one side to the other. 100,000 years. Not to reach another galaxy. Not to traverse some unimaginable intergalactic void. Just to get from one end of our home galaxy, the Milky Way, to the other. Let that land. Because what I'm about to show you is that this fact, this already mind-bending fact, is merely the opening sentence of a story so vast it will fundamentally rewrite how you see your place in existence. We are going to zoom out, step by step, until the numbers stop being numbers and start being something closer to philosophy. And then, at the very end, I'm going to flip the entire thing on its head. Because there is a twist. And it changes everything. Let's start with what we are actually proud of. In 1977, humanity launched 2 spacecraft into the void. Voyager 1 and Voyager 2, twin emissaries from Earth, sent to survey the outer planets and then keep going. Today, Voyager 1 holds the record as the fastest and farthest human-made object in history. It is screaming through space at approximately 17 kilometers per second. That's over 61,000 kilometers per hour. A speed so fast that if you could drive a car at that velocity, you'd circle the Earth in under 40 minutes. NASA talks about Voyager 1 with a certain reverence. And honestly, why wouldn't they? The fact that we built something in the 1970s that is still functioning, still transmitting data, still reaching us across the darkness, it's genuinely one of humanity's greatest engineering achievements. But here's what we don't say out loud very often. After 47 years of continuous travel at that extraordinary speed, Voyager 1 has covered roughly 24 billion kilometers. That sounds enormous. That sounds like a triumph. And then you do the math in cosmic units, and the triumph quietly evaporates. 24 billion kilometers is approximately 22 light hours. Not light years. Light hours. Meaning that the distance Voyager has traveled in nearly half a century is a distance light crosses in under a single day. If Voyager 1 maintained its current speed, which it can't because it will eventually run out of power, and aimed itself directly at Proxima Centauri, the very nearest star to our Sun, it would arrive in approximately 73,000 years. 73,000 years ago, anatomically modern humans were just beginning to spread out of Africa. There were no cities, no writing, no agriculture. The entirety of human civilization, from its earliest mud brick foundations to the phone in your pocket, fits inside a span of time that is still less than what it would take our fastest spacecraft to reach our nearest stellar neighbor. We have not left our neighborhood. We have barely stepped off our front porch. The cosmic era of human exploration, the thing we celebrate with launch countdowns and mission patches and the word astronaut, it is, in galactic terms, indistinguishable from standing still. And Proxima Centauri, let's be clear, is not some distant exotic destination. It's the next house on the street. It's practically touching us. Beyond it lies a galaxy of 200 to 400 billion other stars, and we can't reach even the closest one in any meaningful human timeframe. So that is our starting position. Earth. One small planet. And a civilization that is, cosmically speaking, going absolutely nowhere. Now let's talk about our galaxy. Because even after you absorb the Voyager reality check, the Milky Way still sounds impressive. We live in a spiral galaxy. It has hundreds of billions of stars. It has a supermassive black hole at its center. It has complex structure, stellar nurseries, ancient globular clusters, dark lanes of interstellar dust. It is, by every human measure, stupendously large and stupendously complex. Let me give you a number to anchor its scale. If you wanted to count every star in the Milky Way, if you sat down and counted one star per second, without sleeping, without stopping, It would take you somewhere between 6,000 and 12,000 years to finish. More than all of recorded human history, just to count the stars in our own galaxy one by one. That's the Milky Way. Our galaxy. The thing we call home. Now meet IC 1101. IC 1101 is a galaxy located about 1 billion light-years from Earth. And it is not a normal galaxy. It is the largest galaxy currently known to science. While the Milky Way spans roughly 100,000 light-years across, IC 1101 stretches across approximately 6 million light-years. It contains an estimated 100 trillion stars, somewhere between 250 and 500 times more than our entire galaxy. But raw numbers can be abstract, so let's make this physical. Let's run a thought experiment. Take IC 1101 and place it exactly where the Milky Way sits right now. Center it on our position. Let it expand outward the way it actually exists in space. The Milky Way would be swallowed instantly. That's obvious. But here's what's less obvious. The Andromeda Galaxy, our nearest large galactic neighbor, sits about 2.5 million light-years away from us. IC 1101 would swallow Andromeda too. It would engulf the entire local group, the cluster of roughly 50 galaxies that the Milky Way and Andromeda both belong to. All of them. Gone. Absorbed into a single structure that, from the outside, would look like one enormous, glowing, roughly spherical blob of ancient stars. IC 1101 isn't a galaxy in the way we typically imagine galaxies. Dynamic, spiraling, youthful. It's an elliptical galaxy, ancient and bloated, the gravitational graveyard of countless smaller galaxies it has consumed over billions of years. It sits at the center of a massive galaxy cluster, feeding and growing and simply existing on a scale that makes our home look like a single grain of rice dropped on a football field. And here is the thing that I really need you to feel. IC 1101 is not the universe. It's not even a meaningful fraction of the universe. It is one data point, one structure among billions. The universe doesn't stop at IC 1101. Not even slightly. To understand what actually exists out there, you need to understand how structure works at the largest scales. Because the universe is not a uniform fog of evenly distributed galaxies. It has architecture. It has a skeleton. And when you see that skeleton, something in your spatial intuition simply breaks. Individual galaxies, even enormous ones like IC 1101, are not isolated. Gravity binds them together into clusters. Clusters are bound into superclusters. And superclusters are connected by enormous filaments of dark matter and gas, vast cosmic highways that stretch across hundreds of millions of light-years, into a structure that astronomers call the Cosmic Web. Start with our own position in this web. The Milky Way belongs to the local group. About 50 galaxies, held together by mutual gravity, spread across a volume roughly 10 million light-years across. In the context of what's coming, this is an almost invisibly small dot. The local group is itself part of a larger structure, the Virgo supercluster. This supercluster contains hundreds of galaxy groups and clusters, sprawled across a region approximately 110 million light-years wide. For decades, astronomers considered this one of the largest coherent structures in the observable universe. Then, in 2014, a team led by astronomer Brent Tully at the University of Hawaii published a paper that redrew the map. They introduced us to Laniakea. The name comes from the Hawaiian language and means immeasurable heaven. And the name is not an exaggeration. Laniakea is a supercluster of superclusters, a vast gravitational basin that encompasses the entire Virgo supercluster as just one small component. It contains an estimated 100,000 large galaxies. It spans roughly 520 million light-years in its widest dimension, and it has a total mass equivalent to approximately 100 million billion times the mass of our Sun. The Milky Way sits near the outer edge of Laniakea, like a small town on the fringes of an unimaginably vast metropolitan region whose center we will never reach, whose extent we can barely map, and whose existence we only recently discovered. Let me build the chain for you, step by step, so you can feel each link snap into place. You are here, on a planet roughly 12,700 kilometers across. That planet orbits an ordinary star, not a particularly large star, not a particularly bright star, just one of the unremarkable middle-aged yellow stars that the galaxy produces in enormous quantities. That star sits about 26,000 light-years from the center of the Milky Way, somewhere in a region called the Orion Arm, a minor spiral arm of a mid-sized spiral galaxy. Not at the center. Not in a particularly special location. Just out there, in the suburbs of a structure containing several hundred billion other stars. That galaxy, the Milky Way, is one of roughly 50 galaxies in the local group. The local group is one component of the Virgo supercluster. The Virgo supercluster is one of the smaller lobes of Laniakea. And Laniakea. Laniakea is one of an estimated 10 million similar superclusters in the observable universe. 10 million. At each step, you are not simply getting bigger. You are watching everything you previously understood as large become negligible. The planet becomes a mote of dust in the solar system. The solar system becomes a pinpoint in the galaxy. The galaxy becomes a dim speck within the supercluster. And the supercluster itself becomes an almost imperceptible point within the greater architecture of everything. By the time you are standing at the scale of the observable universe, looking at all of it, all 93 billion light-years of its diameter, all its billions of galaxies arranged in their vast filaments and voids, Laniakea is barely visible. And you, sitting on your planet, in your solar system, in your galaxy, in your local group, in your supercluster, in your corner of everything, you are not a rounding error. You are below the resolution of the image. Now I need to tell you something that makes all of this worse. That observable universe I just mentioned, it is not the same as the actual universe. And the distinction matters enormously. When astronomers use the phrase observable universe, they are not saying everything we've managed to see so far with our best telescopes. They are not describing a technological limitation, a horizon that will expand as we build bigger instruments and send them farther from Earth. The observable universe is a hard physical boundary, a wall built not from matter but from the nature of spacetime itself. Here is why. The universe is expanding. This is not controversial. It's one of the most well-supported facts in all of cosmology, confirmed by multiple independent lines of evidence. Galaxies are not flying apart through space like debris from an explosion. Space itself is expanding. The fabric of the cosmos is stretching. And critically, there is no speed limit on how fast space can expand. The speed of light limits how fast things can move through space. It says nothing about the space itself. At very large distances, the expansion of space is fast enough that distant regions are moving away from us faster than light can travel through the intervening distance. This means that light from those regions will never reach us. Not because it's been blocked. Not because the universe has a wall. But because the space between us and those sources is expanding faster than light can cross it. The observable universe is simply the sphere within which light has had enough time, since the Big Bang, to reach our position. Its edge is called the cosmological horizon. And that edge is not static. Every second, galaxies that were previously reachable, galaxies from which light was, in principle, heading toward us, cross that threshold. Their light redshifts, stretches, and fades. Eventually, it never arrives. Think about what that actually means. Right now, at this moment, while you are watching this video, thousands of galaxies are permanently crossing the boundary beyond which we will never see them. They are not being destroyed. They still exist. They may contain stars, planets, and for all we know, civilizations of their own. But the fabric of space is pulling them away faster than information can travel, and they are slipping behind a curtain that will never be lifted. The universe is not only unimaginably large, it is actively hiding itself from us. It is, in real time, closing off rooms and sealing doors and making itself less knowable by the second. This is not science fiction. This is a straightforward consequence of the physics we understand best. And it means that the observable universe, already a structure so large that the numbers describing it cease to feel like numbers, is itself only a small, finite window into something even more vast, something we can never fully map, something that may be effectively infinite. At some point in the past several minutes, a rational person would be forgiven for feeling something close to despair. After all, consider what the mathematics tells us. Consider what the numbers say about our significance. You are a biological organism living on a rock roughly 12,700 kilometers in diameter. That rock orbits a star that is, to put it charitably, average in every measurable way. That star is one of perhaps 400 billion in a galaxy that, when placed next to IC 1101, looks like a dust grain next to a boulder. That galaxy is a peripheral member of a small galactic group, which is one lobe of a supercluster, which is one of millions of similar structures spread across a cosmos so large that the speed of light, the fastest anything can ever move, becomes a crawl, a shuffle, a slow trudge through an incomprehensibly deep space. The numbers say, plainly and without sentiment, that you are less than negligible. They say that the matter composing your body, the electrical signals firing through your neurons at this very moment, the brief flicker of consciousness that is your life, all of it, in the language of cosmic scale, rounds down to zero. A rounding error in an equation that doesn't know you exist. This is what the universe looks like through pure mathematics. And I've been building toward this conclusion deliberately, because I want you to feel its full weight before I tell you why I think it's completely wrong. Here is the thing about IC 1101. That galaxy, with its 100 trillion stars and its billions of years of accumulated mass and its position at the center of a massive galaxy cluster, it has never had a thought. Not one. In all its vast, glowing, incomprehensible existence, not a single moment of awareness has arisen within it. It processes nothing. It knows nothing. It has absorbed dozens of smaller galaxies over cosmic time and registered none of it. It simply exists, enormous and entirely blind. The Laniakea supercluster, 100,000 galaxies, 520 million light-years across, inconceivable mass, has never experienced curiosity. It has never asked a question. The filaments of the cosmic web, those vast dark matter highways stretching across hundreds of millions of light-years, have never looked at themselves and wondered what they are. Dark matter, which makes up roughly 27% of the universe's total energy content, cannot reflect. It has no interior life. It bends light and shapes structure and is utterly, permanently unconscious. The universe, for all its staggering material abundance, is almost entirely dark. Not just in the optical sense, in the experimental sense. Incomprehensibly vast quantities of matter and energy, organized into breathtaking structures, unfolding across billions of years, and almost none of it has ever seen itself. Almost none of it has ever been seen at all. And then there is this planet. This small, unremarkable, cosmically insignificant rock, orbiting its unremarkable star, in its unremarkable position in the outer arm of an average galaxy. On this planet, 4 billion years of chemistry and chance and catastrophe and evolutionary pressure produced something that had never existed anywhere in the observable universe before, at least not that we can confirm: awareness, consciousness, the ability of matter to become curious about itself. You are, as far as we know, the universe's only mechanism for self-reflection. When you look up at the night sky, the universe is not simply being observed. For those few seconds, the universe is observing itself, through you. When you process the information in this video, when you feel the scale begin to click into place, when something in your mind shifts as you try to absorb the distances and the numbers, that shift, that process of comprehension, is not happening in a vacuum. It is happening inside a cosmos that, without minds like yours, would continue to expand and contract and burn and cool and never once know that any of it was occurring. The stars in IC 1101 will shine for billions of years without any of that energy ever being converted into understanding. The filaments of Laniakea will persist for cosmic timescales without producing a single moment of experience. The observable universe will expand and cool and eventually dim toward heat death, and if consciousness like ours disappears before then, all of it, all 93 billion light-years, all the billions of galaxies, all the dark matter and dark energy and ancient light, will end having been fundamentally unwitnessed. You are not lost in the scale. You are the scale's only audience. I want to be careful here, because I'm not making a claim about cosmic purpose. I'm not saying the universe was designed to produce observers, or that human beings occupy some special metaphysical position. The evidence doesn't support that, and intellectual honesty matters too much to reach for comfortable conclusions. What I am saying is something more specific and, I think, more interesting. The universe's material dominance over you is total and absolute. There is no scale at which your physical size competes with its size, your lifespan with its age, your energy with its energy. In every material comparison, you lose by a margin so overwhelming that losing doesn't quite capture it. You are simply not in the same category. But there is one thing, and as far as we know, it is only one thing, that the universe cannot do for itself. It cannot turn around and look. It cannot hold a fact in mind and interrogate it. It cannot feel the strange, vertiginous sensation of recognizing its own vastness and being undone by that recognition. The fact that you can feel something right now, some version of awe or insignificance or wonder, that feeling is not nothing. That feeling is, in a very real sense, the universe's most improbable achievement. The emergence of complexity sufficient to become self-aware is not a foregone conclusion of physical law. It is extraordinarily rare, potentially unique, and it happened to produce you. Every number I've given you tonight is real. The speed of light. Voyager's 73,000-year journey to Proxima Centauri, the 100,000 light-year width of the Milky Way, IC 1101's 6 million light-year diameter, Laniakea's 520 million light-years, the 10 million superclusters in the observable universe, the galaxies crossing the cosmological horizon right now, slipping forever beyond our reach. All of those numbers are accurate, and they all point in the same direction. The universe is ancient and enormous and indifferent. It will persist long after you are gone. It was here long before you arrived. On any physical scale, you do not register. But the universe has been unfolding for 13.8 billion years without being understood. Galaxies have been born and died without being named. Light has traveled for billions of years without being received by any conscious mind. The entire performance has been happening in an empty theater, or almost empty. And you walked in. Maybe that's not consolation. Maybe knowing that you are the universe's improbable instrument of self-examination doesn't make the numbers smaller or the distances less lonely. Maybe the vertigo remains. That's fine. It should remain. A cosmos this large deserves to leave you a little breathless. But before you close out this video and return to your day, to its ordinary scale, its human proportions, its familiar geography of rooms and streets and faces, I want you to carry one thought. Somewhere in the Laniakea supercluster, in the outer arm of a mid-sized spiral galaxy, on the third planet of an unremarkable star, a collection of atoms arranged itself into something capable of looking at the universe and feeling small. The universe has been doing extraordinary things for 13.8 billion years. That might be the most extraordinary thing it's ever done.